A very good noon to one and all. Now, let us move to the measurement of thread elements. So, in order to find accuracy of a screw thread produced, it is necessary to measure various elements, whether it is okay or not. So, those elements are major diameter, minor diameter, effective or pitch diameter, pitch, thread angle, and thread form. Okay, now let us study how major diameter of a screw thread is measured. So this instrument is known as bench micrometer. So you can see the very rugged cast iron base of instrument, wherein there is a slide which can be moved parallel to axis of the bench micrometer. Slidable body houses the micrometer head. A large diameter micrometer is fitted, and anvil also is there. When we rotate thimble, an anvil moves in or out, and then we have a table to accommodate workpieces of different sizes. We can see a fiducial indicator. This will indicate what is the pressure or force applied on the workpiece. So if we over pressurize the crust of thread, anvils will try to crush the crust, so we don't get proper reading on the table surface. So we can put some fixtures to hold the workpieces on the table surface. So by in this in order to ensure that all the measurements are made at same pressure, a fiducial indicator is used, which it ensures the constant pressure for all the measurements. So the instrument has a micrometer head with a vernier scale to read to the accuracy of 0.002 mm, and it is used as a comparator in order to avoid pitch errors of micrometer threads, zero error setting, etc. A calibrated uh, setting cylinder or master cylinder or general cylinder having nearly the same diameter as the major diameter of thread to be measured is used as a setting standard. That means a standard diameter, setting standard. Okay, so a calibrated setting cylinder is used as a setting standard, which is nearly same diameter as the major diameter of thread to be measured. So the setting cylinder or standard cylinder is held in between the anvils, and reading is taken. So in this mission, there is no provision for mounting the workpiece between the centers, and it is to be held in hand. The cylinder is then replaced by the threaded workpiece, and again the micrometer reading is noted. Okay, so by this uh, we can measure the major diameter of screw thread. So if D equal to diameter of the setting cylinder or standard cylinder, and R1 is reading of micrometer on setting cylinder, and R2 is reading of micrometer on screw thread, then the major diameter of screw thread is equal to the D plus or minus of R2 minus R1. Okay, so the measurement is taken at two or three positions along the thread to determine any taper which may be present, and at least two, preferably three angular positions to detect ovality. Okay, so the any other measurements besides the bench micrometer, any machine used the measurement of effective diameter can be used to measure major diameter with slide modifications in this setup. Okay, and we can conveniently used outside micrometer also to measure the major diameter. The care should be taken to see that the crusts of the thread are not over pressurized. When we move the anvil, we should take care that as soon as the anvil just touches the crust of the thread, we should stop the rotation of thimble. So again the procedure is the same. Reading is taken with standard or setting cylinder. That means R1 we get, and then standard cylinder is removed, and a screw thread is placed in between the anvils, and reading R2 is taken on by using this relationship. We can calculate the major diameter of the thread. So R2 is taken on the major diameter of thread. By using this relationship, we can calculate the major diameter of a thread. So in this uh, the reading is taken with the standard or setting cylinder, then R1, so that is R1 we get, and then standard cylinder is removed, and required screw thread is placed in between the anvils, and reading is taken. So by using this formula, we can measure the uh, major diameter of thread. So then major diameter of thread is d equal to s plus or minus d1 minus d2. Okay, so as there is a point contact between the crusts of the thread and the measuring anvils, a light pressure must be applied. So do not handle the micrometer ratchet, otherwise errors due to the formation of crust may be introduced. Okay, now let us uh, understand how the measurement of major diameter of internal thread. So let us understand how we measure the major diameter of internal thread and minor diameter of internal thread. So the minor diameter of internal thread can be measured by using taper parallels and also by rollers. Now, measurement of major diameter of an internal thread. For this, uh, we use a method called casting method. We can see this diagram. There is a workpiece having internal threads whose major diameter is to be measured. Now we have to take a replica of internal thread. So how do we get the replica of internal thread? So you can see this arrangement. So there is a workpiece with internal thread on both sides of this. So we have to keep wooden blocks. We have to keep the wooden blocks, and then we have to pour it either plaster of Paris or dental wax or sulfur also can be used, and we allow it to settle, and then once it dries, we have to remove the wooden blocks. So we have to remove the plaster of Paris, solidified plaster of Paris. Without rotating the plaster of Paris, we have to just lift it. So we should take care that while pouring plaster of Paris. Okay, so by using this uh, by using this solidified solidified part, by using this bench micrometer, we can measure major diameter of internal thread. So again, in the cast that is obtained, we should measure R1 and R2. So we should use the equation to find the major diameter. Okay. Okay, now uh, measurement of minor diameter of internal thread by using the uh, taper parallels. So for the diameters less than 200 mm, the use of taper parallels and micrometer is a very common method for the measurement of the minor diameter. So the taper parallels are pairs of wedges having parallel outer edges. So the diameter across their outer edges can be changed by sliding them over each other as shown in this figure. So the taper parallel are inserted inside the thread and adjusted until firm contact is established with the minor diameter. So the diameter over the outer edges is measured with the help of micrometer. So by using this we can measure the minor diameter of internal thread. Okay. Now by using the rollers and slip gauges, so this method is used for diameters more than 20 mm diameter. So in this method, precision rollers are inserted inside the thread, and proper slip gauges also inserted between the rollers. Okay, so that firm contact is established. The minor diameter is then the length of slip gauges plus twice the diameter of roller. Okay, so I hope everyone understand this measurement of minor diameter of internal threads. So in this lecture, we have discussed about the uh, what are the uh, what is the screw thread terminology, what is screw thread terminology, and how these screw threads are made, and how the measurement of thread elements. So in this major diameter of measurement of major diameter of screw thread, so by using the bench micrometer, and by using the outside micrometer, and major diameter of internal thread. Okay, so in this lecture we will discuss about the pitch measurement, measurement of pitch for the screw threads. So by use of pitch measuring machine, and, tool maker's microscope, and by use of screw pitch gauge, and by use of profile projector, then we will move on to the uh, effective diameter measurement. So wherein by use of two wire method, and by use three wire method, and by use of thread micrometer. Okay, now we will start the screw thread measurement for the pitch measurement. Okay, so the most commonly used methods for measuring the pitch are uh, by use of uh, pitch pitch measuring machine, and by use of tool maker's microscope, and use of screw pitch gauge, and by use of profile projector. Okay, now this diagram shows the pitch measuring machine. So we have the base made of cast iron, very sturdy base, and we have a centers, and these two centers are provided for mounting the screw thread. Then there is a carriage which will move parallel to the axis, and then in the carriage there is a stylus mounted on a spring loaded head. Okay, and then we have two indicators. So one is a fiducial indicator, and it's to ensure that same pressure is maintained throughout the pitch measuring. And then the other indicator is K, to indicate that stylus is in proper location. Okay, and then we have a micrometer. So by using this micrometer, when we rotate the micrometer, the head, the measuring head will move. When the measuring head moves parallel to the axis, the stylus will move in against the spring pressure. And then when carriage further moves, it will move down into the groove, and it's get setted in the next groove. The distance moved from the first position to the next position will give us the pitch of the screw thread. Okay, a set of styli is supplied along with the machine. So along with the selection guidelines, depending upon the type of thread, and pitch of thread, etc. So we have to select the appropriate stylus. Okay, and then we have to mount the stylus in the head. So accurate positioning of the stylus between the two flanks is obtained by ensuring that the pointer K is always opposite to its index mark when readings are taken. Okay, and the point T ensures uniform pressure while measuring. So when the stylus is accurately placed in position, the micrometer reading is noted. The stylus is then moved along the next thread space by rotation of the micrometer, and a second reading is taken. The difference between these two readings is the pitch of thread. So readings are taken in this manner until the whole length of the screw thread has been covered. Then the average pitch value we can be calculated. Okay. Now this picture shows the arrangement of pitch measurement. So we can see uh, we have a center on which a screw thread is mounted, and we have a bar which carries the stylus. The stylus will move from one thread to the next thread, and it gets seated into the in the thread groove, and then micrometer reading is taken. Okay, and then it is moved to the next thread. So like we can measure the pitch, and the stylus always contacts the flank approximately at the pitch line. Okay, and now uh, internal thread measuring machine. So how to check the pitch of internal thread? So we can see here the arrangement is we have a bar which carries the ball ended stylus, and there is an arrangement to mount the workpieces with workpiece with the internal thread. The bar along with the stylus will move in, and it gets seated into the thread. So bar moves into a groove of thread up to the pitch line. So bar moves into the groove of thread up to the pitch line. With the help of micrometer, reading is taken. So similarly, move on to the next and gets seated, and reading is taken. Then the difference will be the required pitch of the internal thread. Okay, so I hope everyone understand this internal thread measuring concept, pitch. So internal threads pitch. And now okay, now uh, there is a next one is a tool maker's microscope. So with the help of this we can find out the pitch of the screw thread. So this is a versatile instrument based on optical means. It consists of a heavy hollow base accommodating the illuminating unit. Okay, so work table is mounted on the base of instrument on cross slides and is equipped with the accurate micrometer screws to move it in two mutually perpendicular directions in the horizontal plane, that means in longitudinal and lateral directions. So the optical head is mounted on vertical column and can be moved up or down and focused over the work. To clamp the optical head, at any desired position, clamping screw is provided. So workpiece is mounted on the glass plate placed on the table. So a light source which provides a horizontal beam of light which is reflected from a mirror by 90 degrees upwards towards the table. So the beam of light passes through the transparent glass plate on which workpieces to be checked are placed. Okay, workpieces are placed. So a shadow image of the outline of contour of the workpiece passes through the objective of the optical head and is projected by a system of these three prisms to a ground glass screen. So observations are made through the eyepiece of the optical head. So these measurements are made by means of cross lines which are engraved on the ground glass screen. So the screen can be rotated through 360 degrees and the angle of rotation can be read through an auxiliary eyepiece which is provided on the optical head. So different types of graduated and engraved screens and corresponding eyepieces are used for the measuring different elements. So for example, a revolving screen for measurement of standard thread will contain all the basic profiles of all standard threads in various pitch ranges and also various included angles of the thread. Okay, so and by using this uh, we can measure linear measurements and measurement of pitch of screw and measurement of thread angles, etc. So by using this instrument we can measure like this. Okay, now we will briefly discuss about this optical system. So now this is the optical system of microscope. So you can see the body which has a lamp. Normally tungsten filament lamp is used and there are a set of lenses, collimating lenses to get parallel beam of light and there is a mirror using which the light beam is diverted and we have a glass plate over which we can place the workpiece. So workpiece should be placed, that means a screw thread is placed on the glass plate and light with pass through the light is passed through the workpiece and we get the image which we can observe through the eyepiece. Okay, now these tool makers microscope they have a movable and rotatable tables. The table can move the x and y direction so that we can take the measurement and it can be rotated also. So this would be very useful for measuring the thread angle of the pitch thread angle of the work pieces. Okay, so in this the optical head can move up and down for focusing purpose and there is a glass plate on the work table to mount the workpiece so that light will pass through the glass plate and we get the shadow image and light sources are provided which will give us a horizontal beam of light which is reflected by mirror by 90 degrees upwards towards the table. Okay, and surface illumination is also possible whenever we want to measure the surface characteristic of workpieces. This surface illumination can be used and the image means contour of workpieces is projected on the ground glass screen, so which has a scale and a rotary scale, so as well as it has cross hairs by using which we can take the measurement. So the measurements are made by moving cross lines engraved on the ground glass screen, and the magnification can be selected depending upon the size of workpiece. If it is very small, then higher magnification can be used. Similarly, the light intensity we can also be selected. So light intensity we can also be selected. Now we will move on to the use of screw pitch gauge, which is used for pitch of for measuring the uh, pitch of screw thread. So this picture shows a set of leaves. So you can see here arranged in a handle, and the what is the pitch value is marked on each leaf. So by using the trial and error method, we can measure the pitch of the screw thread, and a light source is needed to check the pitch. That means we have to select the leaf which will match it, and so it to be seated. So a light source is considerable. So the light passes in between the pitch gauge and the workpiece, then the match is not perfect. Then we can change the gauge. So this process will be done until the light stops passing between the pitch gauge and workpiece. Okay, so I hope everyone understand this. So there is a light source, and there is a leaf. We have to select the leaf depending upon the requirement, depending upon the size, depending upon the shape of the pitch. Okay, so by using this uh, we have to uh, pass the light source in between the pitch gauge and the workpiece. If it's passed, then it is not a match. Okay, so this process will be done until the light stops passing in between the pitch gauge and workpiece. If it stops, then it is matched. So like this we measure the pitch by using the pitch gauge for the screw thread. Okay, so I hope everyone understand this procedure. Okay, and now profile projector. Profile projector is also used to check the pitch of screw threads. So this working principle is almost similar of tool maker's microscope. When the profile projector, the image of workpiece, that means screw thread, is obtained on the ground glass screen, and then by moving the image against the reference cross lines, we can measure the thread elements like pitch, thread angle, etc. Those elements can be measured. So very delicate and small screw threads can be easily measured by using the profile projector, and thread profile is thread profile is amplified, and parameters are measured by movement and comparison methods. So in this chart gauges are used for comparison purpose. So depending upon the type of screw thread, whether it is Whitworth thread or metric thread or Acme thread, so you should select appropriate chart gauges, and chart gauge should be mounted on the giving screen. So this is the chart gauge. So there is a chart gauge, so which will have two contour lines and then we should obtain the image of contour of the workpiece. So if the image lays between two lines on the chart gauge, then this image obtained. So if it lays between these two lines, this is corresponding to the one is corresponding to the maximum size and other one corresponding to the minimum size. So there is a tolerance band. So if the image contour is well within the tolerance band, then the workpiece is accepted. So it is a comparison method. And in movement method, on the screen we observe two cross lines and we want to measure the pitch of the thread. Then we fix the cross line to meet the crest, and micrometer reading is taken, and again we move to the successive crest. Then by micrometer reading, then by using the micrometer, we move to the uh, we move the crosshair to the successive crest at the same point. Then the reading is taken in the micrometer. So those two readings difference, this difference is considered as a pitch of screw thread. Okay, so I hope everyone understand this. In the previous topic, in the tool makers microscope instrument also is same procedure as like in movement method. Okay, so in tool makers microscopes, there is a we have a in the construction, we have a 2 micrometers. Okay, so we have 2 micrometers, one is a horizontal micrometer and the other one is a vertical micrometer. So depend upon the situation, so the movements of crosshairs can be adjusted by using these 2 micrometers. So if you want to calculate the pitch, if you want to move the crosshairs in horizontal motion, then we have to use the horizontal microscope, horizontal micrometer. If you want to move the if you want to calculate the depth or diameters of the screw thread, then we have to use the vertical micrometer. Okay, so I hope everyone understand these 2 micrometers differences. Those are in inbuilt in the uh, tool makers microscope. So I hope everyone understand these pitch measurement techniques, uh, pitch measurement of screw thread by using these various techniques, various methods. I hope everyone understand this lecture. Please read well, stay home, stay safe.